Welcome back to Further Solutions Academy. Don't forget to share this video, subscribe if you have not subscribed before. On this video, I'll be walking you on a particular part of mathematics which is called mathematical induction. It's a very simple part of mathematics. In this area, we talk about series mostly. We talk about proving of a number. For example, there are videos on this part which is but I have some question which is being posted to me. I have to solve it before we move on. Okay, allow me to write out the question. Okay, this is the question. I'm asked to prove that x raised to power n minus n raised to power n is divisible by x minus n. X minus y for all natural what number. For all, what are the natural numbers? You have to understand what is called natural number. Natural numbers are commonly used what number. It means positive side of integer. That is what I will explain that. Now, when we talk about natural number, we are talking about number, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth to infinity. Now, when we talk about natural number, you have to understand that very well. That is very first thing. And you know that n is a number of what? Let's try to solve this problem and let's see how it will go. Now, I have a particular question which I want to work on. The same thing is that what I'll first do is that assume or for, you can use a word assume or for, don't use let's. Now let's say assume or for n equals to 1. It means I'll be having x1 minus y1, which is it what? It is true that what is divisible by what? X minus 1. We can see that x raised to power 1 minus y raised to power 1 divided by what? Which is going to be 1. You know all these things. Now, that is the first assumption. The next assumption is that if I want to move on, I'll say that for, that is the second one, n equals to 2. Now, I want to move on to n equals to 2. What I just need to do, I'll be having x raised to power 2 minus y raised to power 2. Now, with the help of difference of this square, I can move on by saying that x x minus y and x plus y, which is difference of 2 squared. With this, you can see that it is true that what? By that that x raised to power, x2 y2 raised to power 2 is divisible by this is divisible by x minus 1. You can see that. That is second. I will now move on to by saying that for n equals to k. For n equals to k. Now I want to do the one of for n equals to k. Since I know that this is correct, it means I will now say that what? S raised to power k will be equal minus, y raised to power k. Now, you know that. Now, with all this, will be true. Will be true. Will be divisible. Let me use the word will be divisible. Divisible by s minus y. Now, I will now move on to the next one. Assume that what? For n equals to k plus 1. That is when the work is now. Now, this is where the technicality is. Now, the next thing I will do for n is equals to 1, n minus 1. What I will do here is that I will have what? X raised to power k plus 1 minus y raised to power k plus 1. Now, look at how do I manage this type of question? This type of problem. I can express this as, take note of this, very important. I can say that what? X raised to power k plus y, and I can say that minus x raised to power k plus x y k minus y raised to power k plus 1. Now, mind you, this particular part I'm just trying to improvise for a zero, you know, identity. If I have -1 plus 1, it will definitely give me a 0. You can see that they are having the same coefficient. Now, at this point, I will move on by saying that k raised to power 1 multiplied by s raised to power k and s raised to power 1 minus x y raised to power k plus x y k minus y raised to power k multiplied by y raised to power 1. Now, at this junction, you know, I've done something very good for myself. Now, I will move on by saying that what can I do here? I know that my x is common in this part, which is going to be k minus what? Y raised to power k, and plus, what is common here? I have y raised to power k, which is going to be x minus y. Now, you can see that, yes, x minus y. Now, the next thing I will do now, look at this. Look at it. I want to know, I don't know, maybe it will be divisible by this function or not. Now, at this junction, if I decide to divide this thing by k, by x minus y, now, I want to divide this by x minus y. Truly, it will be what? X bracket of xk minus y, plus y raised to power k bracket of x minus y. Now, if I have x minus y, and if I have x minus y, now you can see that this, we divide this. And this, because it is being divided, it is true that what? Now, it means this also will divide this. You will now draw a conclusion by saying that what? At any given value of x bracket of x raised to power k minus y raised to power k and y raised to power k bracket of x minus y, it will be divisible by x minus 1. That is our conclusion. It means that is the answer. That's all. You can see the way I move on. I tested for 1. I tested for 2. I move on to the k, which is k count, and also move on to the what? K plus 1. You know, I still have one more. Because of time, I wouldn't like to do it here. Don't forget, you are home with Further Solution Academy. Thanks for watching.